So, hello to everyone. I hope there are all of us. Убавь там чуть-чуть на ноутбуке, типа звук. So you all know me by now. I'm Oleg, Vlad's partner at CNT. Today is the stage 4 of our internships and training at CNT. And so today we are working on hydro separation concentrates. We just finished the final fraction, the finest one, in which we are looking for mono mineral grains of sulfide. And now we would like to see how much grains we have in our concentrate, and each fraction is the most productive for sulfides. So I would like to show you how we do the final concentrate by a short glass tube. And while Alexander is doing that, we will discuss what we've done during these days. So we processed the. Okay, let me show you the presentation. You know, we're still in process. We are drying out the HS products. Freeze one. Okay. So let's see on the main screen what we've done during these stages, in these 4 days. Okay. So since we have started yesterday, we are finishing the hydro separation process, and we have made HS concentrates from the following fractions after wet sieving of the EPD Spark 2 and Spark Blend products. So we received the core Spark EPD product. It's shown on this main screen. Took the aliquot of it's about 1/40 part of. Саш, как будет 1/4? It's a little bit less than half of the whole fraction, and we disaggregated it with EPD Spark 10. After that, we done yesterday the wet sieving, and at this photo is showed all the fraction we observed for sulfides. So the coarsest fraction plus 1 millimeter is empty for sulfides. We looked carefully by binocular, and there are no any intergrowths left. Also, we took a look for the fraction of -1 plus of 0.05 millimeters, and it also did not contain any intergrowths or monomineral grains of sulfide. But we're still in process of looking for fraction 0.5 and 0.25 millimeters. And now we will do the hand picking from the HS concentrate of this fraction for sulfides. let me show you also the difference between Spark 10 and Spark 2 products. So this is a liquid before Spark 10, and this is the result of segregation with Spark 10 after about 200 pulses. Okay. So we will now check together with you if we achieved the goal of this project and recovered and concentrated enough sulfides from the sample of gabbro norite. For this, I would like to check the coarses fraction is 0.5 plus 0.25 millimeters. For that, we will eject the grains in a special plastic bag. Let me show how it looks. Там кто-то в чате что-нибудь пишет. So this is simply like that. This is a whole amount of HS concentrate. Let me show it into our special program. But it still have a lot of zoom. It's really hard to show you that. So what we see here, at this fraction, the most of sulfides still stay in the as inclusions of with pyroxenes, with plagioclasses, but they still are heavy, and we see that all grains, most of them are looks like intergrowths. You see, when we try to let me just rotate my camera on, because okay. No, it's not better. Sorry. It is really hard to show you how to make a hand picking, so I would like to continue on microscope. And let me show you some other product. For example, the light fraction, which consists only of light minerals. Okay, that's it. This is a just tailings, uh, more tiny fraction. This is fraction uh, 125 to 63 microns. So as you can see, the grains are much less in sizes. It's still water because we're still in process. So, Саня, а у тебя там в трубке что? Доводку будем показывать или как? Ну ты сейчас хочешь делать? После перерыва? Ну, я не знаю даже. Ну ладно, давай я тогда начну. А ты там подключишься, да? Нет, я буду отбор делать. Окей. Ведро, конечно, там еще не втянуло. So this is a fraction. We working with a fraction 0.5 to 0.25 millimeters. To select the grains of sulfide and collect them in a special container, we use a steel stick, a stick made of steel, or a wooden stick. With a wooden stick is much easier to collect them because some of the grains could have magnetic properties, and it's really hard to separate them from stick made of steel. Also, while we are doing the hand picking, we can always to detect concrete We can detect which minerals we see, to write down the list of minerals we have seen, which we have collected, and use this later when we make a special task or case for operator of different analytical methods. Сашка, как будет терпение по-английски? Терпение как будет? Так. Давай посмотрим. There are a lot of really beautiful grades. The with octahedric, gabitus. Oh, I have found the monomineral grain of chalcopyrite. Just place it there. I hope you can see. Oh, let me turn the camera a little closer. Patience, patience. Of course, this work is not so simple, as you can be very accurate in collecting the grains and moving them between your containers. The main goal is to not lose anything. I think next time we will stream the image from binocular, but it still doesn't have such technical thing. I've collected already about 15 grains of monomineral sulfide grains. Most of them are chalcopyrite, but also there are still many grains with bronze, shiny, with a bronze color. Chalcopyrite have an yellowish color, sometimes with oxide oxide core crust, yeah. Okay. So for this current case, we are looking for at least 50 grains of sulfide, as it would be enough for isotope analysis. But also, after we have done with sample preparation, we need to request the client what kind of mineral analysis are needed for further mineral research, as there are many methods at grain size level that can be used for mineral identification. Depending on the method of choice, we will able to produce sufficient samples. So these will be either volume grains on carbon scotch tape, duct tape, sorry, or monolayer polished sections for secondary electron microscopy and electron microscope microprobe microanalysis, as well as for laser ablation ICP MS analysis. Alternatively, we can send them, for example, for XRF, X-ray fluorescence, or X-ray diffraction analysis as a powder specimens. I would like to mention that some of grains are so soft. I would like so as you pull them with your stick, you can crush them. You know. I mean, Саш, как будет хрупкий? Huh? Fragile, yeah. Fragile. Some of them are fragile, mostly pyrite. I think this is connected with the genesis of this gabbro, alright? Because pyrite grains could consist of several crystals of pyrite, and then we touch them, they are simply crushed. Also, there are a lot of octaedrical grains of magnetite or chromite. Oh no, it's magnetic, so it's magnetite. Okay. Another alkapyrite grain. It's really not so simple to attach them to the stick because they are jumping in and out. Okay, let's change the stick and use a wooden one. There are really small amount of sulfides in a source sample. By the whole chemistry, we know that content of sulfur is about 5 0.05%, so it's about 200 grams per ton of sulfides. But we still can see them, and more of that we can collect them as we concentrated them with a hydro separator. And also we still have a lot of grains in a coarse fraction even after EPD spark 2, spark 10. The sulfide are not contaminated, not crushed, and not lost. Who knows, maybe there are a lot of platinum sulfides or palladium sulfides. I think it's still platinum because this is an ultramafic rocks, gabbronorite, and this sample was with was detected near the contact zone of mineralized vein. По-моему, Саш, я их все достал. И сроски, и не сроски, и все равно мало. А, ты можешь мне дать тот же концентрат, я его сразу сделаю. Ну как, он уж высох, наверное, же там мало воды-то. So I've already have collected about 30 grains. Let's take a look how they looks like. But it's still not enough for isotope analysis. Mm-hmm. Sure. Okay, I hope it works. Let's change the window. Okay. So this is a monomineral. I mean, all grains consist of only one mineral. This is not an intergrowths or inclusions of various minerals. All grain consist only of one mineral. This is a fraction. So as we use uh, scale, we can measure each grain, its sizes, and also we can describe the morphology of grains. And also, as I mentioned, we do the special list of minerals we observed and use it in task in next level of our studies. Let me collect all sulfide grades in one place to see to show you how much of them we have liberated and concentrated with our 3D lab, with our technology. So okay, let's continue with another fraction as I've extracted all grains from this concentrate. There are only another heavy minerals left. And let's check time tiny fraction. Another one. This is a fraction 250 microns to 125 micron. You also put whole material in a special container. We have to do it very carefully, as if we lose something, that would be catastrophe. Okay, at these fractions there are a lot of sulfides, as they have a special grain size distribution in nature. Also, I have to mention that for more deep research we can provide tailings after hydroseparation to chemical analysis for understanding of recovery factors for different sulfides or platinum group elements or even gold. But this is out of the scope of this study, so we just extract sulfides from concentrate in a special container and we will return that to our client. Let me show you. The sulfides I've already collected, and I will continue another fraction in another container. Что ты будешь делать как в финале концентрата? Чё? Что можно сказать про гидротермальное месторождение? Ну что есть постмагматический процесс, как правильно, имеет импульсивный характер. Еще раз как? Какова роль наложенных деформаций, в результате которых образовались родоносные жилы на березовском месторождении? Ну какова роль? Она главная, она является несущей благородно-метальную минерализацию. Самое главное, что ты должен понимать про гидротермальные процессы, что они, как правило, имеют амплитудный характер. То есть это не разово у тебя температура была высокая, потом охладилась и все выпало. У тебя, как правило, сначала теплая, потом похолоднее, что-то садилось, потом снова температура поднялась, у тебя что-то растворилось, что-то там новое образовалось и так далее. То есть это многостадийные процессы. Да. И на это тебе и надо указывать. Постмагматические процессы, это говорит о том, что у них один источник, магматический комплекс, который являлся типа золотоносным, ну, точнее, в нем типа формировалась золоторудная формация. Блин, ну это нереально с этой фракцией уже работать. Как тут отберешь-то, ёптать? Какие-то хуйни накрошил. Нет. Ну это просто нереально, они не цепляются, понимаешь? Не, ну самое мелкое вообще просто должны быть чисто моносульфидные концентраты. Так, попробуем тогда заточить ножик. I should be very accurate with every grain I collect, because they are 2 times smaller than previous fractions, so it's 2 times more difficult to extract them by hand picking, but we should still do it very carefully. There are a lot of grains. This is a fraction of 250 microns to 125 microns. So I think all the sulfide grains are just 100 microns in diameter. Sometimes we can use our spill to let grain catch by stick. Also, I can see a diamond here, very shiny and transparent grain. I think it's olivine because very isometric. Саша, ты сделал конвертики с кальки? And 45. There are 5 grains of sulfide left. Oh, it stayed there. Just a moment. There are a lot of chalcopyrite grains with characteristic rainbow skin. They are yellowish and they have rainbow skin. You know what I'm talking about, Alexander? Alexander doesn't speak English at all. So as I am, but I can watch TV series in origin without any saps and understand everything they are talking about. But myself, I am talking very bad because I don't know how to remember every word during your speech. I don't know exactly how I can do it in Russian language, but in English it definitely much much more difficult. I would like to say that I can talk to you by meme phrases like from movies, from podcasts, etc. So I've done with that sample, and now I will move all grains to the center of this container, as we have a very narrow screen of view because we magnify more than 100 times by our digital microscope camera. Okay, so this is the grains I have collected by hand picking. It is not so difficult as it looks like, but you really have to be patient, accurate, and have a very good eyes. Sorry, I have some troubles with the camera. And once again, this is a fraction 0.5, 0.25 millimeters. There are 40 grains of different sulfide. Let me exaggerate the video. Okay, just a moment. Ка? А? Ну, напиши. So, sorry, I had a special call from our partner, and also I've tried to select the whole to unite the fractions in one product. So I also tried to move all grains in one spot to show you on our digital microscope, but still they are not uh, in one image, but we can see that we have there at least three different mineral species. All right, this is sorry, I will try to show you with my stick. This one is bronze color. This is a pentlandite or pyrotin. This yellowish one is chalcopyrite. There are a lot of grains of chalcopyrite also. And we also have some intergrowths of pyrite with pyroxene and olivine, and also have monomineral pyrite grains on this. After that, we pack all material we've collected using our hands and special sorry so let me show you once again light fraction to show you the difference of product we received. There are no any grains, no intergrowths, no sulfides, no intergrowths with sulfides. There are only light minerals like quartz, amphiboles, and etc. So we take all our collected grains. Also, I would like to show you the special pack we use in our studies for transporting the final material. Okay, looks like that. This is a special paper bag. Oh, sorry. This is a cake and paper. Thin paper, water resistant paper, which we sign up by our pencil or pen. I don't know exactly how to pronounce pencil. This is pencil or pen, and this is ash sulfide sample 2. Sulfide. So we just move all grains in our paper bag. Also, I would like to write down the fraction of sulfides we see here. It's zero point 0.5 minus zero point 0.5 plus 0.125. So now we've finished, and the next stage, as I mentioned, we have to request the client what kind of mineral analysis are needed for further mineral research. There are a lot of methods as we can use for mineral identification, but the most common is secondary electron microscopy and electron probe microanalysis. In this case, I think they would use a gas method of analysis, of isotope analysis, as the goal is to find the light isotope of sulfur. And such lazy geologist entity. Okay. Now we have to repeat the whole operation of sample prep for another samples, and I hope we see each other next day or at the same time. So we will discuss how we analyze the EPD and the HS product, how we check the weight of each product, build the histograms, graphics, and etc. Also, we are thinking about same online seminar or webinars talking about analytic methods for which HS and EPD product fits better than any other sample preparations method. And also we have to discuss how to make a final report on our studies, because different it's no matter what kind of specimen we processing, I mean ultramafic or felsic intrusion samples, or we use or we study technogenic material. We always do the same operation. We always do first EPD Spark 2, second we do perform EPD Spark 10. After that we do wet sieving, hydro separation, and sometimes ultrasonic sedimentation. And after that we observe, we look every hydro separation product carefully for gold mineral grain. Sometimes it could be gold grain, sometimes it could be sulfides, or zircon, or any other base metals minerals like magnetite, chromite, and etc.